Welcome! Today we'll solve a challenging volume problem using the method of cylindrical shells. We need to find the volume of the solid obtained by rotating the region under y equals sine of x squared from x equals 0 to x equals square root of pi about the y-axis. Let's first visualize the curve and the region we're rotating. Here's our coordinate system. And here's the curve y equals sine of x squared from x equals 0 to x equals square root of pi. When we rotate this region about the y-axis, each vertical strip becomes a cylindrical shell. Let's look at one such shell. At any x value, the shell has radius x, height sine of x squared, and thickness dx. The volume of each cylindrical shell is given by the formula 2 pi rh dx, where r is the radius and h is the height. In our case, r equals x and h equals sine of x squared. To find the total volume, we integrate this expression from 0 to square root of pi. Our integral becomes 2 pi times the integral from 0 to square root of pi of x sine of x squared dx. This is a challenging integral that requires a substitution. Let's let u equal x squared. Then do equals 2x dx, or x dx equals do over 2. When x equals 0, u equals 0. When x equals square root of pi, u equals pi. Our integral becomes pi times the integral from 0 to pi of sine of u do. This is a basic integral. The integral of sine is negative cosine. Evaluating from 0 to pi, we get negative cosine of pi minus negative cosine of 0, which equals negative 1 minus negative 1, which equals 2. Therefore, the volume equals 2 pi cubic units.